Greetings, my name is Justin and today we'll be talking about triple integrals in spherical coordinates. So, what is spherical coordinates? Spherical coordinates is different than rectangular coordinates and it is existing in the form of rho, phi and theta. And we can see from this graph here, the positioning of rho is here, which is denoted in length, and phi and theta as angles. So, if we take a look at the important equations we would need, first we would find x squared plus y squared plus z squared equals to rho squared. And this is very important because it's derived from the equation of radius in the sphere and we'll be using it. So if we take a look at the similar graph earlier, we draw a line perpendicular between z and rho and we are able to find out using Pythagoras theorem that z equals to rho cos phi and r would equals to rho sine phi. So we do that again on the xy plane using Pythagoras theorem and we are able to see that x and y is equals to rho sine phi cos theta, rho sine phi sine theta. So now we have all x, y and z. We are able to solve problems using the integrals. dv would be equals to rho square sine phi d rho d phi and d theta. So these are the differentials. And now talking about integrals, the volume is simply the integral of 1 dv. And the mass, where we see a function of rho, phi, and theta, is actually the function of density which exists in this three unknown form. So similarly, we dv this, and if we sub the values of dv we found earlier into this equation, we're able to see that volume is the triple integral and whatever dv we have said earlier, and mass is function of density plus whatever dv we see earlier. So that is all from me. This is the theory and foundations, and my friend will be explaining the example problems and using the theory. Thank you.
Good morning, my name is Im Chok Hwang. So now I'm going to show and explain the example of the question. So this is our questions. Evaluate triple integral tan xz plus 3dv, where E is the region portion of x squared plus y squared plus z squared equal to 16, with z bigger or equal to 0. So how are we going to know for our object? So we simply insert the information given. So this we can know. This is what we can know. Okay. So now we are going to know what is the phase. So the phase is actually the z-axis, z positive axis to the p. So p is over here, along here. So we can know it's from 0 to 90 degree. We can see over here 0 to pi over 2, which is 90 degree. So for our phase, since is on z equal to 0, so the theta is going to be 2 pi. So for our p is actually known as radians. So by square root 16, we can know that we can get 4. So 4 is our radians. So we know that x equal to rho sine phase cos theta, z equal to b cos phase. Okay, so by simply replacing inside, this is what we can get. This is what I can get equation. These are equations. So by integrate it over p, first over p, so this is what we get, and substitute the value 4 to 0 inside, and this is the final for what we get after integral over p, integrate for p. Okay, 2048 sine square phase cos theta plus 64 sine phase. Okay, so next we're going to integrate it for theta. Okay, against theta, so this is what we get. After integrate, substitute 2 pi and 0. So we get 128 pi sine phase. So we integrate this against phase again. So we get negative 124 pi cos phase, and then substitute pi over 2 and 0 into the equations, so we can get the final answer is 128 pi. So that's all from me. Thank you.
Salam Doctor, my name is N Keng Hong and I will now start explain the questions for spherical coordinates of triple integrals. So this question is it asks us to evaluate the x squared plus y squared, where E is the region portion of x squared plus y squared plus z squared equal 4 and y is bigger than 0. So from here we can know that this is a spherical, because when we sketch it in Geogebra it get us a spherical here. Then uh, we this is a list of formula that we use when we need to evaluate the spherical coordinates triple integral. So then we start to sketch the graph here. Then we know this is a spherical and then y is bigger than 0. So which means it is a half spherical towards the y-axis. Then after we get this, we can know the limits of the rho, phi, and theta. So to find the rho, we know we can calculate here. Rho is equal to 2, and then phi and theta we know this because it is a spherical here. And then we start to imply this for list of formula into the equation that we need to calculate. So after we sub the value here, we can get x squared plus y squared is equal to rho square sine square phi. Then we start to write down the all the limits here into the integrates, into the triple integrates, and then we can integrate all, and where we use by parts, and then we can get the final answer as 128 over 15 over 15 pi. Thank you.
Hi and good day to everyone. My name is Teo Kimi Kwan and I will explain applications of triple integral in spherical coordinate to solve problems. So the first one is to find total charge in sphere cloud. So we are given a charge density and we need to find total charge contained within a sphere. So the total charge is equal to triple integral of charge density over a volume of a sphere. So x squared plus y squared plus z squared, we know that it is equal to rho square, and we can plug in into the equation and we get a simplified versions of the equations. Now we can set the limits of the integrals. So the first limit is for rho, which is the radius from 0 to 10 given in the questions. The second one is phi, which is from 0 to pi because the sphere is a full sphere from top to bottom. And finally, the theta is from 0 to 2 pi because the sphere is a full sphere of 360 degrees. Now we get the full equations and we can apply triple integral to solve for the problems and get the final answers. Next is the applications is to find total power in sphere antenna. So we are given power density and we need to find total power. So we can apply the same thing, triple integrals of power density over a volume, so we can get a total power, and we can calculate it and get the final answers here. So actually I'm not focused on calculations because what I want to emphasize more on this part is actually triple integral in spherical coordinate actually can be used to solve electrical engineering applications problems. You can use to solve various type of problems. So the next one is this is more to spherical coordinate applications in real life. So the first one is facial asymmetry analysis in mandibular prognatism patients, which doctor can use this approach to help them to make accurate and detailed analysis to fix the facial misalignment problems of patients. Next is this shows a geometry of general radiating antenna placed at origins of spherical coordinate system. So actually the magnetic fields and electric fields of the antenna can be represented in spherical coordinates. So engineers can use this to model various far fields antenna parameters. That's all from me. Thank you.